Hello, Algebra 1, and in this video we're going to talk about fractional exponents. Yes, we can even have exponents that are fractions. And fractional exponents are just another way of writing a radical. So what we see here are two radicals that are implying the same exact evaluation. So we have the fifth root of 8 to the third. It can also be written as the fifth root of 8 raised to the third power. So both of these radicals mean exactly the same thing. The power can be written under the radical sign or on the outside, and they both mean exactly the same thing. And if we were going to rewrite them in the form of a fractional exponent, they would turn into simply 8 to the 3/5 power. And what we see here, and I've got it color-coded, is that the index of the radical, which is 5 in both of those, becomes the denominator of the fractional exponent. And we see that the numerator here, this particular 3, is the same as the power. So the power is the numerator and the index is the denominator. So that's how we can rewrite a radical as a fractional exponent. So we're going to be doing some evaluations in this video. So evaluating fractional exponents. And the first thing we're going to do, and we're going to stick with this 8 to the 3/5, is we're going to rewrite it as a radical first. So now we're going backwards based on what we just saw. So remember, the denominator of the fractional exponent is the index of the radical. So let me highlight that. So there's my denominator and there's my index. And once again, that power or that numerator is going to be the power of our radical, and I normally prefer to write it on the outside. And from here, we're going to simplify the radical based on the steps that we've already learned, and then we're simply going to follow order of operations, gems. So inside we've got the fifth root of 8. So we've got to think about this. The fifth root of 8, well, 8, if we go to our factor ladder, of course, is 2 times 2 times 2. So what we see here is when we replace the 8 with 2 to the third, nothing is actually going to come out. So being that I've got this exponent on the outside, maybe I do need to bring it onto the inside. So remember what I said? That the power can be written either under the radical or outside. I'm going to move it in, and now I'm going to apply the property of exponent, the power rule right here. So if we have the fifth root of 2 to the third, if we follow the properties of exponents underneath that radical sign, which remember, the radical sign is a grouping symbol. And if we're going to follow order of operations, we're going to deal with what's inside, or in this case, underneath the grouping symbol first. So here, what we've really got is the fifth root of 2 to the 9th. So can the fifth root of 2 to the 9th be simplified? Yes, it can, according to the procedure that we've been using. So if we now divide our power by our index of our radical, 5 goes into 9 one whole time with 4 powers of 2 left over. So 8 to the 3/5 is going to reduce down to 2 times the fifth root of 16. So this is what it would be as a simplified radical. Now we're going to be looking at some that are a little simpler than that, And because 3/5 is certainly not a fractional exponent that we're going to see often. So let's take a look at some that we are going to see often. And this first one I use a lot. If we have 64 to the 1/2 power, then that means if we rewrite it as a radical, and remembering that our denominator of our fractional exponent is going to be the index of our radical, and then the base never changes, and then of course it's to the first power. Now normally we don't write the first power. I'm just writing it here to remind you that the 1 there is the 1 that is here. So hopefully everybody knows that the square root of 64 is simply 8 without even having to do a factor ladder. So we can make a generalization here. We can say this: the 1/2 power is the same as a square root. The 1/2 power is exactly the same thing as a square root. So the square root of 64 is 8. We simplified. Now let's look at 81 to the 3/4 power. So once again, we have the denominator of our fractional exponent is the index of our radical. So we have a 4th root of 81, and that 4th root of 81 is being raised to the 3rd power. So the 4th root of 81 is one that we have seen a few times while doing our practice problems. So if we were to make a factor ladder for 81, 81 divided by 3 would be 27, divided by 3 would be 9, divided by 3 would be 3. So 81 is actually 3 to the 4th power. If we replace that 81 with 3 to the 4th power underneath our radical sign, remembering that the radical sign is a grouping symbol, so we're going to do what's underneath first, and we're going to simplify here. 4 goes into 4 one whole time. So the 3 is going to pop out, and then we're still going to raise it to this 3rd power. 3 to the 3rd is 27. So 81 to the 3/4 power is going to evaluate all the way over to 27. Let's do it again with 1,000 to the 2/3. Let's rewrite it as a radical. The denominator of the fractional exponent is the index of our radical, and the numerator of the fractional exponent is going to be the power outside of the radical. So we have talked a bit in class about powers of 10, which is what 1,000 is. And 1,000 has 3 zeros, and if we were to make a factor ladder for 1,000, if we started with 2's, it would go to 500, it would go to 250, 125. 125 is no longer divisible by 2, but it's divisible by 5, and by 5, and by 5. What we have here is 2 to the 3rd and 5 to the 3rd, which really is the same thing as the cube root of 10 to the 3rd. 1, 2, 3 zeros, 10 to the 3rd power. We would get the same thing if we put underneath the radical sign the cube root of 2 to the 3rd and 5 to the 3rd. 2 would come out and 5 would come out, which is the same as just the 10 coming out here. So we end up with 10 squared, and of course 10 squared is 100. So 1,000 to the 2/3 power is the cube root of 1,000 raised to the 2nd power. That's 10 to the 2nd power, which is 100. So number 4, remembering that we are always following order of operations. So if we know that the 1/2 power is the same as a square root, let's quickly change both these to being radicals. So 144 to the 1/2 power is the square root of 144. And if the 1/2 power is the same as a square root, then the 1/3 power must be the same as a cube root. So the 1/3 power is the same as a cube root. Whoop, there it is right there. And 125, we've seen that number quite a few times now. The square root of 144, 144 is a perfect square, its square root is 12. The cube root of 125, 125 is a perfect cube. We've seen that one several times. 125 divided by 5 is 25 divided by 5 is 5. 1, 2, 3. 125 is 5 to the third. So the cube root of 125 is 5. We're following order of operations, so we're performing the grouping symbols first. Then we will subtract. 12 minus 5 is 7. Let's do it again down on the bottom. And we have 81 to the 3/4, which we have already simplified previously on the page. That was 27. And then we have the 4th root minus the 4th root of 16. The denominator of the fractional exponent is the index of the radical. So if we are going to simplify the 4th root of 16, we are going to need to use a factor ladder. So back to our factor ladder for 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 16 is 2 to the 4th power. So if we replace it, and I'm just going to bring my 27 along for the ride here, minus the 4th root of 2 to the 4th. So 4 goes into 4 one time. So 27 minus 2, 27 minus 2 is 25. So there are some evaluations using fractional exponents, and we'll stop there.